Yeah, so the next person who's speaking, I'm very, very excited to have talk. He is one of the people who first taught me good unit testing strategies and how to love quality code. Matt has been a mentor to a lot of engineers in Calgary and developers in Calgary. And he's just a general all-around awesome person. So when he offered to speak on observability, I knew he'd have some good stuff to say. So yeah, Matt, do you want to talk about your journey with observability?
Sure, thanks, Jacqueline. Okay. Okay. Everybody can see my slides, I hope.
Yeah.
Okay. Thanks, Jacqueline. So I'm going to talk about observability, and observability is really about being able to ask questions about, arbitrary questions about your code as it's running, and especially if it's in a complex environment. But I'm going to go way back to the beginning and talk about grad school. So way back when I was in grad school, I was writing software to just simulate electromagnetic wave propagation, which is interesting. But the thing about that was, when you're a grad student, you want to go to conferences and present your work and experience all the fun things that you can experience. And I had an opportunity to go to Hawaii and present a paper there. So the problem was that I needed some data to build that paper out. And in order to get the data, I needed to simulate a very large system, and I needed to simulate it within 24 hours. The people who ran the supercomputers that I was using would only give me the machine for 24 hours, and then if I ran over that, they'd kill it, and I would have no data, and I wouldn't get to go. So this code is a very simple idea, and I'm sure everyone has done it when they've wanted to time something. It's just, when did I start? When did I finish? How long did something take? And this very simple idea is how you can tell when you're changing your code, whether you're making it faster or you're making it slower. How does it respond to those changes? And with this very simple technique, where I'm just logging out like a plain text message, there's not even a timestamp on this, right? It's just a duration. But this allowed me to measure whether the changes I was making were having an effect. And fortunately, I was able to run that huge job, get my data, write my paper, and go to Hawaii and present that and explore the island and do all the fun stuff I got to do. So, the nice thing about this is, like, not a real big consequence. If I didn't get it done, I would be sad I didn't get to go to Hawaii, but oh well. Let's skip ahead a few years. I'm now working on a web app, and this web app is pretty complicated, has a lot of user state. It has lots of machines. There's web servers. There's other servers that those web servers talk to. There's like databases and Redis and lots of complexity. But we have a course coming up. We've sold our product. We want to have it used for training, so that people can learn on it and hopefully take it into their into their clinical practices when they go out into the world. And so we want to make sure it works. We're going to have a lot more users than we've ever had on the system before at one time, lots of concurrent users, and we want to make sure it works. And we're a little worried. And so we wanted to like simulate load on the system and make sure that it was going to perform as well as we wanted it to when those real users came in, because we didn't want it to suddenly break, and we weren't super confident. So what we did was set up simulated users, essentially. EC2 instances or lambdas, sort of like clicking on the web app and doing things to simulate those users coming in and putting load on the system. And sure enough, we ramped up that user load and things started to break. And we're very worried about how are we going to fix this? And all we had was logs. So this is so we had structured logs, we had timestamps, free-form text messages. Some of those messages were correlated together, but when you're trying to figure out where a performance problem is or where something's breaking, that can be sometimes really hard when you're just looking at free-form text. Like, how long did this take? I can I have a log message at a certain timestamp and a log message a little later, and I'm trying to compare those in my head and think, that looks like it took a couple of seconds. And sometimes you have to do things like narrow the window down. So this screenshot is this is 500 milliseconds, and there's 75,000 log entries here. And you have to sometimes comb through that and process of elimination. I've got to look through this haystack to try and find the one thing that's going to solve my problem and tell me what's wrong with this system so I can fix it. Fortunately, this is where the sadness comes in of the story. Is this was literally weeks of looking at these logs and trying to figure out what was happening and running these tests and maybe adding a little bit more logging or adding more tagging, session IDs or user IDs or request IDs, so that we could correlate those log messages and try to understand what was happening in the system. We managed to get it done. We got the number of users that we needed to support, and we were able to get the course, and it worked, fortunately, but it was painful. In the next step in the observability journey is visualization. So we've got all this data in logs. How do we turn that data into something that we can actually see visually and tell a story? Because when you're trying to compare timestamps and look at just text in your head, it's pretty hard. And when you put it on a graph like this, any gaps and things that are supposed to be in parallel or serialized or something pop right out. So I really love the visualization that you can do with some of these observability tools, and not even tools. This graph was generated by pulling logs, kind of correlating them, figure out when things start and stop, and just produce this with Vega. So the story here is we had a new product that was coming online. And essentially, it's all about ingesting data from a hospital. A patient comes in, they get a scan, we take those images and we run some inference on them, generate an AI result, and we want to get that back to the doctor while the patient is still there with the doctor. That allows a fast turnaround time so that they can start to get the value from running those AI algorithms as soon as possible. But our challenge was there's all these little gaps in our system where data would come in and then it would get queued up for a while we waited for something to happen, or there would be too much data coming in all at once and we wouldn't be able to handle the load. So how do we figure out where those bottlenecks are and what we can do about them? And by plotting a graph like this on a timeline, kind of a waterfall, we can start to see where the different phases of the process are, where those gaps are, because those gaps pop right out. You can see the spaces between the bars. You can see what bars are taking longer than you might expect. And so by being able to see this, you can really zoom in on those areas that you can make effective change. So this kind of graph helped us understand that, and is an ongoing monitoring process that allows us to understand how well we're doing as new data comes in all the time. The next step in my observability journey is to really adopt observability APIs, essentially. So I had the good fortune of being able to work on a greenfield project for ingesting data and bringing it into our system. And I had the freedom to choose an API to help me with keeping track of this. So I go from writing one-off, start and end time and printing out a duration, to being able to generate structured log messages that show, that capture all of that information and all of the tags, that all of the identifiers and all of the things that might be happening with that. So this is a structured log message, and it's showing that we have there's a duration, a finish time, so we can see where things start and stop. That allows us just enough data to produce that graph. And then it's tagged with some of the things that you might see from an HTTP request, and what the status code was and the method and things like that. And the downside of this sometimes is the volume of the logging, because observability is about being able to ask arbitrary questions about what's happening in your system. And in order to do that, you want to capture a lot of context and a lot of the events that are going on. And so when our director of engineering saw the volume of logging that was coming off of the system, he was like, "Oh my God, why are we capturing so much logs? This is like going to be so expensive to store and to gather just in terms of that infrastructure. You've got extra infrastructure to do that." But it paid for itself. I think over time we were able to recognize that, hey, things are getting slow for some reason, and we could go in here and understand, oh, it's the database is getting slow because it's starting to see too much load. We can scale that database up and it starts to pay for itself. So going from structured logs allow you to produce graphs that look like this, which really show, like, over the course of an HTTP request, I can see all of the systems that it interacts with and how they work. And whether things are happening in parallel when they should be, or whether things are unexpectedly serialized. So again, this kind of visualization really helps understand what's happening in the system. And it's kind of the key takeaway, I guess, is like capture structured events, move from free-form text towards structured logging, and use tools, even simple tools like scripts and tools like Vega to generate graphs if you have to. You don't need a fancy UI necessarily, although that certainly helps. If you want to learn more about observability, I highly recommend the book Observability Engineering, which is a free ebook from the authors who run the company Honeycomb, which is a great observability tool. And I also highly recommend checking out the OpenTelemetry observability primer. They also have OpenTelemetry has a bunch of tooling for capturing telemetry from your programs, distributed traces, logs, metrics, that sort of thing. So I highly recommend checking that out if you're interested in observability. That's all I had. Questions?
That's really cool. Jay is saying you might like checking out LTS log.
Its log.
Its log. Okay. What is its log?
Cool. It's a framework for structured logging in .NET.
Nice.
That is very cool. David, you've got your hand up.
Yeah. So in your experience, what has been the largest hindrance from developers adopting structured logging? What keeps them from taking this massive benefit tooling that the company is already paying for, because you're collecting a bunch of data from other systems? Why not all developers are adopting this?
So I think generally, like, observability or even logging in general is kind of a cross-cutting concern. I've seen, so it can kind of get in the way of business logic. And you're like, oh, I just want to implement my feature. In system or in languages like Go. So for example, Go doesn't have things like thread local storage. So you have to manually propagate the information that allows you to build those traces. So that can be one factor. Another is just like, it's more stuff to worry about. Like it can be even hard to convince developers sometimes to create log messages that are focused on the people who need to run the system. And when they get paged at 3 a.m, they'll see messages like, oh my God, WTF sometimes, right, in the debug logs, because people will not recognize that they are not the audience for that message. So unless your developers are also operating the site, or operating the system, which is good, possibly good practice. I think that would be an interesting discussion. It can be hard to feel that pain that people who need to, optimize performance or keep the site up at 3 in the morning feel. So
Yeah, I think
Thanks.
feeling the pain is an important way to get change happening. And if you don't feel the pain, then it's hard to change things that might be making things harder for other people. So thank you very much, Matt. Observability is super valuable. And I know in my applications, data applications, we want a good way to figure out how to make things observable. But right now there's no good way to do it for data engineering pipelines, which is frustrating.